Right, now what we're going to do is look at how to draw 3D diagrams and predict the shapes and bond angles of molecules and ions. The best way to do this is to look at some examples of molecules and ions and then just draw them and see what the process is. By doing several, you'll get the idea how to tackle these kind of questions in an exam. So let's start off then with any old how, just to have a look. Okay, here we are, CLF3. That's not the final drawing. Okay, now here the key is to write down or draw in the electron pairs. So chlorine, you know, is in group 7, so it should have 7 electrons in its outer shell. It's using one there, that's fluorine's electron. Another one there, that's fluorine's. Another one there from chlorine, and that is fluorine's. So look at chlorine, it's got 1, 2, 3 electrons it is using, so it must have 4 electrons left over. 1, 2, 3, and 4. In other words, one electron pair, a lone pair, and another electron lone pair. So we have how many electron regions? 1, 2, 3, 4, 5. Now think back to 5 electron regions. Do you remember that? It was something like trigonal bipyramid. Do you remember that? Trigonal bipyramid. And we drew it like this. Let me just explain this 3D drawing now. The dashed line means that the bond is going away from you. Okay? And that triangle or the wedge shape means that the bond is coming towards you, whereas these are in the plane of the paper. So if I was to hold up the trigonal bipyramid, here we are, and I was to hold it like that, can you see that bond angle is coming towards you, and that one is going away from you towards me, and these two and that one are in the plane of the paper, right? So towards you a wedge, away from you a dashed line. Okay, that's how you would draw a 3D shape. Okay, right. Now you also remember that lone pairs sit on the equator. Do you remember? So you can have them there and let's say over there. So we have now, let's redraw this again. Right, 1, 2, and we've got 1 there, and we have 2 lone pairs. Alright, so I want to put them 1 and 2. They sit on the equator, and remember the name of this shape? T-shape. Okay, there we are, T-shaped. Right, 1 second. Alright, and the bond angle will be 90 degrees. Let me just show you that. Here is the here's the trigonal bipyramid shape. I'm going to take 2 atoms off, leaving the lone pairs, and the bond angle here, that's the one we're interested in, and that's 90 degrees. Okay, so that one there, 90 degrees. T-shaped. Right. Okay, next is SF4. So again, just draw a quick sketch. It doesn't have to be accurate. 1, 2, 3, 4. Okay, and now you draw in the electrons in the bonds. So let's do that. Each of these is a single bond. 1 electron from the sulfur, 1 electron from the fluorine. Again there, and again there, and again there. Okay, let's see if there are any lone pairs on the sulfur. Now sulfur on your periodic table is in group 6, same group as oxygen, so it should have 6 valence electrons. In other words, 6 outer electrons. How many is it using? 1, 2, 3, and 4. So it's got 1 electron pair left over. Let's draw them there. 1 there and 1 there. Okay, so now let's see what we have. How many electron regions? 1, 2, 3, 4, 5 electron regions again. So let's now draw the trigonal bipyramid. Right, there we are. trigonal bipyramid. So that gives you some idea what shape it might be. Okay, but remember we have a lone pair, and the lone pair, as you know, goes on the equator. So I've done too many fluorines. Let's just rub off that one there. Okay, and there's the lone pair on the equator. Now, what shape could this be? Do you remember from the first video, seesaw? Okay, seesaw shape. Okay. Okay, now remember that a lone pair will tend to reduce the bond angle by 2.5 degrees. So let's just draw the lone pair there. So now this angle here, instead of being 120 degrees as it was before, it's now going to be 117.5. Is that right? 120 take away 2.5. Yep. And there we are, 117.5 degrees, that one. All right. Right, next one. But the main thing is that it is a seesaw shape. Okay. Next, ICL4. So again, remember what we do? You draw a very rough sketch. It doesn't have to be accurate. There we are, ICL4. And the next thing you draw is the electrons in the bonds. Let's just do that. Okay, if I just draw the electrons in, 1, 2, 3, and 4. So iodine is using 4 of its electrons. It is in group 7, so it has 3 left over, but there's a negative charge. Look, that means an extra electron. So it's got 3 plus 1, 4 electrons left over. So it's going to be 1, 2, 3, 4. Just can't do that properly. There we are. Right, 1, 2, 3, 4, 5, 6 electron regions. Now from 6 electron regions, we know that that has to be an octahedral shape. So let's start drawing the octahedral shape. It's not going to be octahedral because we have 2 lone pairs. But what shape will it be? First, draw it like this. Okay, there we are. And remember, for an octahedral shape, the lone pairs go on the axes. So we're going to go there and there. So now we have iodine. Can you guess the name of the shape? And the name of the shape is square planar. Bond angle, here's a different color. Bond angle 90 degrees. Okay, and the lone pairs sit there and just underneath, which we don't count or look. We don't look at those to name the shape. It's just the actual atoms that we're looking at. Cl, 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 and Cl. So square planar. It's a flat molecule. Next one. In fact, is it a molecule? No, it's an ion. So it's a square planar flat ion. Right, next one. BRF5. So let's do that one. Again, sketch it out. It can be wrong. It doesn't have to be right. Just draw your 5. 1, 2, 3, 4, 5. And then you would, remember, put in your electrons in the bonds. So let's do that. So it's a process that you're using to work out the actual shape. Right, so 1, 2, 3, 4, and 5. Now bromine is using 5 electrons. It's in group 7. It has 2 left over. And if I just draw them in a different color for now. Right, 2 left over. There they are. Okay, now count the electron regions. 1, 2, 3, 4, 5, and 6. So again, it looks like it's based on an octahedral shape. So draw the octahedron as a starter. There we are. Bond going away from you. that bond coming towards you. Now remember the lone pair, where it goes for an octahedral shape, it goes on the poles. So the top or the bottom, doesn't really matter, on the axes. So I'll draw it on the bottom here. There they are. And so now we have a, guess the name, we have a square based pyramid. Bond angles, bond angle, that's 90 degrees, as are all of these also 90 degrees. So you've only got one bond angle, 90 degrees. Okay, fine. Any more? Right, H3O plus. Notice it's a plus sign, that means it's got one less electron. Right, again, just sketch out the shape. Oxygen in the middle, 3 hydrogens. Put them anywhere, because it's a process of working it out first of all. So draw the electrons in. 1, 2, 3. Oxygen is in group 6. It's using 3 electrons. It must have 3 left over, but positive. It's lost 1. So it's only got 2 left over. There they are. Okay, now count the electron regions. 1, 2, 3, and 4. 4 electron regions tells you it could be a tetrahedral type of shape. So let's draw the tetrahedral shape. Oxygen, tetrahedral. Remember, practice drawing these shapes. There's the tetrahedral, and the lone pair can go anywhere. So I'll just draw them here, for example. Alright, you can draw them anywhere, because you can move the molecule around. Right, here it is. Just looks like that, like ammonia really. So there's a lone pair. I can have it anywhere, can you see? At the top or at the side or at the back, doesn't really matter. But it's easier when it's at the top. You can see it's a pyramid shape. Okay, so the bond angle here will be, remember, if it's tetrahedral, it's 109.5 degrees. One lone pair will reduce that 109.5 to 107 degrees. So 107 degrees, and it is a trigonal pyramid shape. Okay, not no more. Okay, and that gives you an idea of how to tackle drawing shapes and working out what it looks like and what the bond angles are. Okay.